I'm talking about AP. So AP is called arithmetic progression. GP will be called geometric progression, and HP would be called harmonic progression. So prior to moving to that, we will understand some of the things here. So any number which you can write like this, say for example, I've written a number here, 2, I've written of 5, and then 8, and then, mm, okay, I am following a sequence, I don't want to follow a sequence. 2, 5, then I'm having say 10, and then I'm having say 17, and then 23, and things like that. So sometimes a number can be written like this, a number which wherein you can identify the first term and the subsequent terms. They will be called sequence. So any number which is written like this, right, wherein you can identify the first term and the subsequent terms will be called a sequence. This any random kind of number. Say, what is this representing? For example, so I would be saying that this number is representing the distance covered by a cyclist every 1 hour. So let's say this guy has started slowly. In the first hour, it is representing that he's covered 2 kilometers. In the second hour, he's covered 5 kilometers, and then 10 kilometers, 17 and 23, and so on and so forth. So, so a sequence can be any kind of arrangement of numbers wherein you can identify the first term and any subsequent terms as well. So this will be called a sequence, all right. And a sequence following, what I am trying to do is I'm trying to define a progression. So then I will come to arithmetic progression. So I'm trying to define all these terms which are there. So first I wanted to tell you that any sort of numbers arranged can be called a sequence. And now I'm going to qualify a sequence. A sequence basically, oops, a sequence following a rule is called a progression. Okay. So what do I mean here? So for example, here, say, let's say I'm looking at first term. So the first term is 2. Okay. If I have to get the second term, then I'll have to say add 3 to it. Then I'll get 5. Okay, this is 2, this is 2 plus 3, 5, and then if I add 5 to the third term, I'll get a 10, and then I'll add say 7 to that, then I'll get 17, and then I'll add 6 to the next term, and then I'll get 23. But what I see here is that there is no fixed pattern, that the first number which is there, I have to add 3 to get the second number, and 5 to get the third number, and 7 to get the fourth number. Till here, I could still see some sort of a rule going on, that it is increasing by 2, 3, 5, 7. And if the next number had been 17 plus 9, I could have said that it's still following a rule. But here, it is not. But let's say I have another sequence which is like this. So I have 2, then I have 5, then I have 8, then I have 11, then I have 14, then I have 17, and then I have 20. So this is going like this. So if I'm looking at this sequence, what I'm seeing is the first term. So how do I represent the first term? Is like this: A1, A with a subscript 1. So A1 is 2. Okay. Now how do I represent second term? A2, A and subscript 2 will be called the second term. And what do I see here? That if I add 3 to the first term, I will get the second term. And say if I add again 3 to the second term, I'll get the third term. And say if I add again 3 to the fourth term, I'll get another term which is 11. Okay, so it's looking like it's following a sequence that every time I add 3 to the number, I get the next number in the sequence. So in general, if I have to write a rule, I can write that a n plus 1 or a n plus 1, let me write it that way. A n plus 1 is a n plus 3, wherein here n is basically greater than equal to 1. And I can as well write here that a1 equals to 2. So if I give you this kind of a rule, then what you will be able to get is that you can form the sequence. How do you form the sequence? Is that okay, you have been given this rule, this is the rule given to you, that okay, a1 is 2. So what I'll do is I'll start putting the number wherein n is greater than equal to 1, and n is a natural number if I'm saying. So n could have values like 1, 2, 3, 4, 5, and so on and so forth. So what I can write here is that I can write a2. Basically, I'm putting n equals to 1. So 1 plus 1 is 2 is equals to a1 plus 3. And what I can see is that a1 is having value 2. So I can write 2 plus 3 equals to 5. Okay. So then if I have to get 3, so what I'll have to do is I have to put 2 here, because a2 plus 1 will become 3, and this will be equal to a2 plus 3, and that will become what? It will become 5 plus 3, and it will become 8. Okay. So now coming back, I was trying to define, okay, that what is a sequence. I was defining a sequence, I was defining a progression, and then I will come to that what is an arithmetic progression. So basically it's something like this, that sequence is a superset. Under that there is a sequence, and under that there will be multiple sequences. So how the structure can look like is this: a sequence is a generic arrangement of numbers. Under that there is a progression. Under that there will be multiple progression. One will be AP, which we'll be learning now. Then there will be GP, which we'll learn later, and then there will be an HP. Okay. I said progression is the one which is following rule. So AP is a specific progression, which is arithmetic progression. And in this, what we say here is that in this kind of progression, which is arithmetic progression, what happens that, say if I have sequence like this: A1, A2, A3, and something like AN. So the rule here which they will be following is that A2 minus A1 would be equal to A3 minus A2 would be equal to A4 minus A3. Means that every term, and if they are subtracted by the previous term, their difference would be constant. So this term and subtracted by the previous term, their difference would be constant, and this difference is called common difference. So I'll give an example, you will understand. This is called common difference, and common difference PD is represented by D. The first term is represented by A1, which I've shown you, and we will see now that AN, nth term, we call nth term of the sequence would be given by a formula which is A1 plus n minus 1 into D. So we'll see what is this, but prior to that, let's look at some example to understand what do I mean here. So simplest AP is this natural number sequence, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's say this is arithmetic progression having only 10 terms. Now, if I look at this, I can see that 2 minus 1 is equals to 1. I can see 3 minus 2 is also equal to 1. I can see 5 minus 4 is also equal to 1. I can as well see 4 minus 3 is also equal to 1. So I can see that every term, if they are subtracted by previous term, their difference is same. and in this case the common difference, which I'm saying, common difference is equal to 1, which we represented by D. In this case, A1 is basically represented by 1. So this is one example. Now there could be other example here. Let say I have even number sequence like 2, 4, 6, 8, 10, 12. I've got so many only. So if I look at here again, what I can see here is that 4 minus 2 is equal to 2. 6 minus 4 is equal to 2. 8 minus 6 is equal to 2. And 10 minus 8 is also equal to 2. And so on and so forth. So even the last one, 12 minus 10 is equal to 2. As I can see that if I am subtracting this term with the previous term, I am getting a constant difference. Which is a common difference, right? So this is also an AP. So this is an AP. This is an AP. Okay. I now I'm taking a different example. Now say this number 1, 11, 21, then 31, then 41, then 51. So if I look at this sequence, this is also an AP. Why? Because 11 minus 1 is equal to 10. 21 minus 11 would be equal to 10. 31 minus 21 would be equal to 10. 41 minus 31 would be equal to 10, and so on and so forth. So again, as I can see, the difference between these two terms are always constant. So I can say this is also an AP. Also an AP. But what about this? If I have this 1, then 3, then 8, then 13, then 19, then 25, and things like that. So if I look at here, if I subtract 3 minus 1, I get 2. When I do 8 minus 3, I get 5. When I do 13 minus 8, I get 5. And I do 19 minus 13 equals to 6. When I do 25 minus 19, I get 6. So though this 5 is equal to this 5, this 6 is equal to this, but not all the ones are actually having the same difference. So that's why it's not an AP. Okay. Now let's look at some example and try to see whether we can solve. So now let's look at the fourth one. Fourth example, not example, but rather this one. So this one we have already done. This is an AP. Let's see that. Okay, let's look at that. So we had 2, then I had 5 by 2, then I had 3, then I had 7 by 2. Okay. All I was saying that an AP has to have the common difference as same. So what will be 5 by 2 minus 2? So I'll take an LCM of 2. Okay. Then can I write it 5 minus 4 equals to 1 by 2? Okay. What about the next one? 3 minus 5 by 2. Can I take an LCM of 2 and can I write 3 into 2 is 6 minus 5, which is also equal to 1 by 2? And now let's look at the third one. 7 by 2 minus 3. Now my LCM is 2 and this is 7 minus 3 into 2 is 6, which is 1 by 2. So as I can say, see here that the common difference is 1 by 2 and the difference between any subsequent term when they are subtracted by the present term is actually same. So because of this reason, it will be an AP. So common difference is basically minus 2. So okay. So as you can see here, the common difference, let me just write it in words here. So the common difference could be positive, negative, fraction, irrational number, anything. All that it has to be same. Okay. So what do I mean by a negative common difference? Say I have a number sequence like this. This is 1. Then I have got minus 1. Then I have got minus 3. then I've got minus 5, I've got minus 7, minus 9, and so on and so forth. All I have to do is that I have to subtract minus 1, this term, minus this minus of 1, which will be equal to minus 2. Then this one minus 3, minus of minus 1 would be equal to minus 3 plus 1, which will be minus 2. In this one, minus 5 minus of minus 3 would be equal to again minus 2. So as you can see here, the common difference is minus 2. It's a negative number, but it is still an AP. Okay. So now let's look at how do I represent an AP. So as I said, we had a first term like A1, and then we were writing A2, A3 like this, A2, A3, and we wrote AN. And what we said that A2 minus A1 equals to A3 minus A2 equals to, oops, A4 minus A3 equals to D, or something like this, right? So in other words, what we can do is, if say if my first term is A and common difference is D, say if I'm saying that this is my first term, or rather let's do this one step. So now, as the common difference is same, so I am writing A2 minus A1 equals to D. I'm saying that this is the fixed common difference. So A2 can be written as A1 plus D, isn't it? So and then similarly, if I have to write A3 can be written as A2 plus D as well. Or say I'm just okay. Let me stop here because this is the next concept. So A2 equals to A1 plus D. So say if I'm saying that A1, the first term, I am saying that this first term is A. I'm just saying that say if my A is like this, I'm saying that instead of calling it A1, I'm calling it A. So my A2 will become A plus D. Instead of calling A1, I'm calling it A. Okay. And A3 is, as I could see, that A3 is nothing but A2 plus D. Here, from here, A2 plus D, isn't it? So A2 was A plus D. So I am just going to write A plus D. And there is a D here. So this will become A plus 2D.
Yes.
Okay, now coming to A4, A4 is nothing but A3 plus D. So if I am just adding the common difference in the previous term, I will get the next term, right? Or other way around that. If I am subtracting a D from the this term, then I'll get the previous term, right? D is actually, I'm saying that I'm assuming this could be any common difference, which is something like this. Say I'm saying that I just know my first term is say 1. I'm calling that my first term is 1. Or let's do this way. Say in this one, I had 2, then 4, then 6, then 8, then 10, right? So here what I'm saying that 4 minus 2 is 2, right? And 6 minus 4 is still 2, and 8 minus 6 is 2, right? So this is what D is. The D is 2. So I am subtracting A1 from A2, so A2 minus A1, or I'm subtracting A3 from A2, A3 minus A2, or I'm subtracting A3 from A4, just like this, right? So what? So the common difference, the difference between any two terms is actually same, and that is what I'm calling it as D. Okay.
Okay.
So
Yes.
if I have to write it here, so I have to write 4. So can I not write 4 as 2 first term plus 2? This is 4. This is the common difference. This is A, right? A plus D. If I have to write 6, I can write 4 plus 2, and this 4 is actually nothing but again A plus D, or rather 2 plus 2, and then there is another 2. So this is something like 2 plus 2 into 2. This is how I'm writing it. So here, what I'm trying to do is, I'm saying here that it is A2 minus A1, A3 minus A2, all the difference is actually D. To get A2, what I'm doing is, I'm just using A2 minus A1 equals to D, or A2 equals to A1 plus D. This is okay. The third term, right? Okay. Uh, okay, let me take another example just to see what. whether we are still getting it. So say I have this rule going 1, then I have got 4, then I have got 7, then I have got 10, then I've got 13, and so on and so forth. So as I can say here, 4 minus 1 will be equal to 7 minus 4, will be equal to 10 minus 7, will be equal to 13 minus 10, and then which is equal to 3. So if I have to get 4, what I have to do is 4 equals to 1 plus d. Basically, I'm sending 1 on the other side with that. Or 7 is equals to 4 plus d. So
Mm.
7 minus 4, I'm taking this part. 7 minus
Okay.
4 is equal to d. So 7 equals to 4 plus d. Yeah, 10 equals to 7 plus d. So can I write 4 as 1 plus d? 4 as 1 plus d. And then there is already a d. So there is 1 plus 2d. Then 7, can I write 1 plus 2d? And then there is a d. So this is 1 plus 3d. This is what I'm trying to do over here. As I could see, instead of writing some numbers, I'm just saying this a1, a2, a3, and all that is there. Okay. And this is an AP. So what I'm trying to do is here is I'm just writing a3 plus d, and a3 is equal to a plus 2d. So I'm going to write a plus 2d here, and then there is a d. So this will become a plus 3d. Similarly, if I go to a5, a5 would be nothing but a4 plus d, and since a4 is a plus 3d, and then there is another d, so I can write a plus 4d. Okay, so the my sequence, if I have to write a1, a2, a3, I can write my sequence as one is a, another one is a plus d, third one is a plus 2d, fourth one is a plus 3d, fifth one is a plus 4d, and so on and so forth. Why? Because if I do this again, if it is an AP, so a plus d minus a, which is nothing but d, then this minus this, a plus 2d minus a plus d, which will be nothing but a will cancel out. It will be d again. Again, same way, a plus 3d minus a plus 2d will be again equal to d. So, can I write a n, the nth term? Any n could be anything. Would be a plus n minus 1 into d. So as you can see, there is a pattern here. The second term is like a plus d. A3 is a plus 2d. A4 is a plus 3d. A5 is a plus 4d. So can I write an or a10, for example, a10 equals to a plus 9d, because it's going like a sequence, right? A3 may there are two d's. A4 may there are 3 d's. A5 may there are 4 d's. So A10 may there should be one less than that. So this is what is called the nth term of an AP. Okay. So I've just talked about the next concept in line, which is called nth term of an AP. Okay. So as you could see that there are multiple examples given here, and we were doing this second term, third term, whatever we were doing over here. And in this case, they have given you this and they're asking you to find the 10th term of the AP. So let's look at this example and then try to solve it so that we understand this concept well. So this is what it is given over here, that find the 10th term of the AP. So what is that saying? They are saying that find the 10th term of the AP. So one thing is that they have given a this is an AP. So if it is an AP, one thing I know that there will be a common difference. So let's find that common difference. So the common difference D should be equal to 7 minus 2 equals to 5, or it could be also equal to 12 minus 7, which is equal to 5. Okay. So I've got the common difference as D. Okay. Now what is my first term? A is my first term and the first term is 2, right? So if I have to get the 10th term of this AP, that will be A10, which will be nothing but A plus 9D, which will be
Mm.
nothing but
Okay.
2 plus 9 into 5, which will be nothing but 47. So why did I use this? Because I know that AN will be equal to A plus N minus 1 into D. So I have put N equals to 10 here, When I put n equals to 10, I get 10th term, and this is 10 minus 1 is 9, so 90. Now let's do another example. So they are asking which term of the AP is minus 81. So they have just uh, twisted this question a little, but the concept is still the same. So let's look at this question. So which term of the arithmetic progression, so this is an arithmetic progression, and the basically the terms are decreasing. So they are saying that tell me which term will this be minus 81. So first of all, if for any AP, I need to know the first term. So I need to know the first term. So A is my 21 first term. I need to know the common difference. So common difference is 18 minus 21, which is going to be equal to minus 3. Alright, so I've got A and I've got common difference and then first term. So they are saying that this is minus 81 is which term? They were asking the find the 10th term here. So I'm just saying that okay, let's assume, let's say the nth term of the AP is minus 81. I don't know the value of n. So, but I know that I'm just assuming that this nth term is minus 81. So I'm saying that okay, what is my nth term? Nth term is a plus n minus 1 into d. Okay, so a is 21, and I'm unaware of what is n, but d I know it's minus 3. And I'm saying that this nth term is equal to minus 81. So I'm saying that okay, minus 81 is going to be equal to 21 plus n minus 1 into minus 3. Okay, so this is also okay. Now this comes this side, so minus 81 plus 21, sorry, not plus 21, minus 21, minus 81 minus 21 equals to n minus 1 into minus 3. So this becomes 102, and then this will become n minus 1 into minus 3. So n minus 1 is equals to minus 102 divided by minus 3, and this will be equal to 34, and then n minus 1 equals to 34, then n equals to 34 plus 1, which is 35. So what I know that this n is 35, it means that the 35th term of this AP is going to be minus 81. What I'm saying here is that see, these three terms are in AP, so they are saying that I have deleted something here. They are saying that this 2 and there is a number missing over here, and then this is 26. They are saying that these three terms are in AP. Can you tell me what is this number is?